Hey everyone, so I'm making a video on how to find mass of a region uh, using spherical coordinates. And with this problem, we're given an object with a density of 1. So we're really just finding the volume, but just using that volume multiplying by a density of 1 so you get units for mass. They'll do that very often to just make the math work out and it still prompt you to do more work. With like different problems, like use mass to find my, then use my to find mxy to find z bar, which we're gonna have to do. I'll show you that in a bit. But what we're given is a region that's like a bowl with a sphere at the bottom and a cone at the top. So we're really just finding the mass of this small region rotated around the z-axis. And we're given equations for both the sphere and the cone. Cone being phi equal to pi over 4. And the reason why I say phi is because that's the way Dr. Tyler says it. So like I used to saying phi, but I normally say phi. And our rho, which defines our sphere, is 2 cosine phi. So I'll go ahead and get started with trying to find mass and setting up the triple integral in order to find our limits. So to find mass, it's really density times volume, with density being 1, so you're doing 1 times our volume. So our volume is going to be our d rho d phi d theta. But one thing you need to make sure you add in is whenever you use spherical coordinates, you add in the rho squared sine phi. It's just like how we add in the r for r d theta. It's just something that you have to be able to put it in order to make the calculus actually right or correct. So moving on. So in order to find the limits for rho, we have to. I want to just give an example before I do it for this one. So say we have a sphere here. You have to, in order to find the limits, you take you start an arrow at the origin and project it outward. So if we hit right here, and with this, say the sphere is rho equal to 5, then you're going from 0 to 5 for the sphere. And the same thing goes for all different types of things, like all different shapes or regions whenever you're using spherical coordinates. So for this one, it looks a little confusing, but you have to see that you start your arrow at the origin and you go out of the spherical part. The reason why you don't go out the cone part is because your region is, because it's not the upper region isn't spherical. It uses phi, so you don't have to account for it. But since we go from since you go from the origin, which is 0, out to and exit out rho equal to 2 cosine phi. So our limits for rho is going to be rho equal to, sorry, I always write my rows weird, so I'll make it a p. Rho equal, sorry, why did I put 0? Why did I put 2? I was supposed to put 0. From 0 to 2 cosine phi. So now we have to find the limits of integration for phi. So phi is always the angle from your positive z-axis to whatever object there may be. So like if you have like a parabola, like a parabolic, paraboloid, and it's like this, you care about the angle from here out until you exit whatever surface it is, and that's your phi. That's what you care about. And in this case, if this entire thing was solid, it would be from 0 to whatever equation that defines this angle. So in the case for this region, we have to take an arrow from the positive z-axis. I'm going to write that as z and put my wire x down. So I'm going to put that down real quick. And you'd use an arrow from the positive z-axis, and you'll see what you entered, then exit. So you enter at phi equals to pi over 4. And what you exit seems kind of arbitrary. It's not really well defined on what it is. But I like how we use in rectangular coordinates to find out like like the very last integral part where you don't like use any equations to define it. This is the same thing. So you have to look at what is the max value of the angle phi on this sphere. And if you think about it, if you draw profile shape, imagine it's a sphere. I know it's not perfect. Here, right there. You have a right angle from right here to your z-axis, and this applies right here. If you can see, I'll draw that in green so you can see better what I'm talking about. So this is your right angle from your. You make this right angle from the bottom of your circle to your positive z-axis. So if it's 90 degrees, then that means your angle phi that it exit outs of. Oh, no. Women in Gender Studies class email. Phi equals to pi over 2, so that's 90 degrees. That's where we exit out when we go out here, because that's the largest angle that it is when it exit out the circle. God, I can't speak right now. I want to say egg instead of exit. All right, back to purple. Actually, too thick. There you go. So it's and it goes to pi over 2. Now theta is easy. You can look at the look down on it. You have y, x, and it goes all the way around. So you have a circle. And to find theta, you have to take for the positive x-axis and do an arrow all the way around until you either hit the same side or exit out the surface. So we're really going from 0 to 2 pi, since that is all the regions that covers the bowl in terms of theta when you're looking at the xy plane. So now we have our limits and integration. Now we can solve for mass. So in order to solve for mass, we can integrate rho squared. Sorry, we have to do our limits integration for do our integral for rho first, then phi, then theta. So we'll start off with 0 to 2 pi. Pi over 4 to pi over 2. And then we'll have rho cubed over 3. From 0 to 2 cosine phi. Then we'll have sine phi in dp, d phi, d theta. Sorry, not p, my bad. I don't know what I'm doing. D phi, d theta. Alright. And well, then we'll get, when we put that in, we'll get 8 cosine cubed phi over 3. So this will equal and we'll have 8 cosine phi cubed over 3. And then we'll have sine phi, which is very convenient because we needed, in order to integrate the cosine cubed, we needed a du, which would be our sine phi, because that's the derivative of cosine. So when we integrate this for phi, we'll actually get 0 to 2 pi. Sorry, 0. Yeah, lost a pi right here. God, I can't wait to get my new laptop. This one is so trash. That's right, making sure I didn't miss anything up here. So we'll have 8/3 times cosine to the 4th phi. And this will be negative, since the integral of sine phi is a negative cosine. And I have to also divide by 4. And I'm going from pi over 4 to pi over 2. So this is 0 to 2 pi. And I'm going to make this negative 2/3. And when I plug in pi over 2 for cosine to the 4th phi, this will go to 0 minus cosine to the 4th of pi over 4 d theta, and this will equal 0 to 2 pi, negative 2 halves, negative 2/3, times negative pi over 4 would be square root of 2 over 2 to the 4th d theta. And this will cancel out our negatives, which is really helpful. So we'll end up getting 2/3, 0 to 2 pi, I forgot about that. 2/3 times 1/4 d theta. Maybe we can go ahead and integrate for theta. This will equal 1 over 6 times 2 pi. So since it would be theta 0 to 2 pi, now equal 1/6 times 2 pi minus 0, which equals pi over 3. Make sure I did that right. Yep. Get pi over 3. So now the next step is they ask us to find m, x, y, and z bar. So mxy implies that we do the same thing we just did to find mass, but we have to multiply by a z. So mxy equals the integral. Since we multiply by a z, we have to translate that z into terms of spherical coordinates. I'm going to get my limits of integration, and then I'll convert z into spherical. C2 cosine phi pi over 4 to 2 pi, pi over 2, 0 to 2 pi. And then we'll have a z be multiplied, but the z would really be, in order to find out what a z is, I normally draw this diagram right here. So I say this is rho, this is phi, this is z. And say we made a triangle here, that was r. So cosine phi would equal z over r, z over rho. So I mean z equals rho cosine phi. So that means I have rho cosine phi here times our normal rho squared sine phi, d rho, d phi, d theta. So then this will equal 0 to 2 pi, pi over 4 to pi over 2. And we'll have rho to the 4th over 4 from 0 to 2 cosine phi. Times cosine phi, sine phi, d phi, d theta. And then this would equal from 0 to 2 pi, pi over 4 to pi over 2 of, it's going to be 4 cosine to the 4th, actually to the 5th phi, because we have an extra phi right here. And then times that by sine phi, d phi, d theta. Now integral of phi, so it's going to be the same thing as we did before, but now we have 5 cosines, cosine to the 5th instead of what we have out here at the top, cosine to the 3rd or 4th, to the 4th. So then this will be from 0 to 2 pi of 4 divided by 6 times cosine to the 6 phi. Sorry, negative cosine, my bad. Of d phi, sorry, not d phi. Yeah, d phi, my bad. Oh wait, never mind, already integrated. Sorry, I'm losing train of thought. My roommates are yelling from the another room about something stupid. I'm getting distracted. Sorry, pi over 4 to pi over 2 d theta. So this will equal negative 2/3. Of course, with our limit of integration for theta still, times cosine pi over 2 to the 6. Like before, that goes to 0, minus cosine to the 6 of pi over 4 d theta, which equals going to be a positive 0 to 2 pi, a positive 2/3 times square 1 over square root of 2 to the 6 d theta, which equals 0 to 2 pi of 2/3 times 1/8. So then this would equal 1/12 times theta. So that's the integral, the coefficient d theta, and 2 pi. So we'll get 2 pi minus 0 times 1/12. And that would equal pi over 6, which equals our mxy. So in order to find z bar, this is the easy part. You take mxy and divide it by m. So we have pi over 6 over pi over 3. Cancel out the pi's. So you have 1/6, 1/3, and that equals 1/2. Sorry, I'm trying to be as concise as possible. I'm still learning. Even when I do the problems like 3 or 4 times, I still struggle to be on top of it when I explain things. So please comment below if you have any questions and put this timestamp on wherever you have issues. I really want to make sure I help you all and give you all as many resources as possible. So please let me know on other ways you think I can help. And again, I know I'm sure I'm boring to listen to. But the big takeaway for spherical is that whenever you do a triple integral, you have to have rho squared sine phi. And how you do the limits of integration, which you have to be able to look at. With rho, you go from the origin outward until you hit a sphere. For phi, you look from the positive z-axis outward, around to the negative z-axis, like this. And make sure you keep track of what you enter and exit. And for theta, that's an easy one you've had several times before. You have to look at the y-axis or y-axis plane and do a circle and see what angles you happen to hit. And for a lot of them, for spherical and cylindrical, you will be going from 0 to 2 pi. Not saying that they'll all be like that, but they tend to be like that. So, like I said, please give me some criticism, comments, anything. I don't care. I want to try to get better. I want to help you all more as much as possible. So please let me know, because I'm not perfect. I really want to get better. I really enjoy helping people. So please help me help you. So, all right. Good luck for your tests.